Good day to my panels. Today I would like to present about my final year and prediction of heavy industrial activities in Kuantan River Basin by deep learning algorithm. Before that, my name is Norfatin Aina binti Cik Hamzah with ID number AA16145. I'm doing my PSM under the guide of Dr. Adriana binti A. Aziz together with 5 other friends. My presentation outline consists of 10 parts, that is introduction, problem statement, research objectives, scope of study, significance of study, literature review, reference, result and discussion, and conclusion. First part is introduction. What is water footprint? Water footprint is the total volume of fresh water consumed in producing every services or goods by individual or community or by business. Blue water footprints refer to the volume of water used and then evaporated or added into a materials in terms of consumption either from the surface or groundwater which is not returned to the reservoir from where it is drawn. And then my study is focusing on heavy industries, blue water footprint calculation and its prediction. Second part is problem statement. The main source of water supply for industrial activities in Kuantan River Basin is from water treatment plant that is also supplied to other sectors such as domestic and agriculture. Water treatment plant treat water that come from the nearby stream. Heavy activities such as bauxite mining can cause contamination to the stream. When this situation occurs, water scarcity will happen due to water treatment that can no longer treat water from contaminated stream. When water shortage issue is arise, all industry and domestic cannot resume their operation because of water shortage. Hence, the blue water footprint for heavy industrial activities in Kuantan River Basin can also cannot be determined. My research objective consists of three objectives. First objective is to inventorize heavy industrial activity within Kuantan River Basin area for 2015 until 2018. Second objective is to determine blue water footprint of heavy industrial activities in Kuantan River Basin for 2015 until 2018. And the last one is to predict the total water footprint for heavy industrial activities based on deep learning algorithm. Scope of study. The study location is in Kuantan River Basin area. There are 5 water treatment plants within responsible to supply water for industrial activities. Those 5 water treatment plants are in Semambu, in Sungai Lembing, Sungai Pancing, Bukit Ubi and Bukit Sagu. And then my study focus on blue water footprint for heavy industrial activities and its prediction, which is a blue water footprint calculation formula and Blaney Crider method. Then deep learning algorithm is used to predict blue water footprint in heavy industries by using method backpropagation. Then the study focus on heavy industrial activities only. For example of heavy industrial activities are textile, mining, petrochemical and many more, etc. Significance of study. To assess the Kuantan River as a water resource that has enough water to be shared fairly among and sector and also sustainable. This is the example of a few literature review from a journal that I read. For this purpose, Kuantan River Basin has been chosen as the area to determine the industry that get water supply from the water treatment plant around Kuantan River Basin. The area coverage is about 1,638 kilometers square. To achieve my first objective, which is to inventorize, to do the inventory for the list of licensed heavy industrial sector with the Kuantan River Basin. This is the step that I need to follow, which is first is data collection and then inventory of data, data cleaning, data classification, types of according to their types of industry, classification, also do based on location of water treatment plant. All this data is stored in Microsoft Excel. The second objective, which is determining the blue water footprint for heavy industrial activity by using formula, the first step that I need to use is I need to do water footprint counting, and then I need to calculate using the blue water footprint equation, which is you can see here. Blue water footprint use water intake, evapotranspiration times with area, and then plus with rainfall times with area. Area is the area of the water treatment plant that we take the data from. To calculate the evapotranspiration, we use the Blaney. I use the Blaney-Critter method, which is consists of mean daily percentage of annual day times hour, and then mean. T mean is the temperature, mean of temperature. Objective 3, which is water footprint of heavy industrial activities, was assessed by using deep machine learning. Previously, the modeling was about the selection of the best hyperparameters. However, due to the MCO period and after discussion with supervisor, I changed it to the method of long short-term memory, a time series prediction. Modeling is just a small part of this research which use application and code that already there. Okay, the first that need to follow before publishing the model is to do the result classifying, cleaning the data by removing all the outliers, then do the normalization of data, do the optimizing at hyperparameter, construct the network architecture, and then training, testing and validation of the data, and finally we can publish the model. From my objective, I need to sort different premises in according to my study, which is heavy industrial activities. Finding is generated into figures based on their respective year. In 2005, there are 69 premises was recorded in the list. Among of the 69 premises, there is 21 premises that is dominating between because they operated some same activities, which is manufacturing. There is a sudden surge of number of premises which increased about 4 premises compared to previous year. 2016 recorded 73 premises that operated in the area. This sudden increment is influenced by the factor that there is high demand in this industry, increasing in population of people and more. Manufacturing sector is still dominating as the biggest sector out of all activities listed in this area. 2 years previously, we can see that the trend for the premises is increase in number. However, in 2017, the number of premises operate actively is suddenly decreased to 67 premises only. Even though the number of premises is decreasing, manufacturing sector still holds as the biggest heavy industrial activities that actively operated in this year too. The decreasing in number of premises can be explained whether their operation already ended due to various reasons like high competition or they already moved their premises to another place. The trend started to increase again in 2018, even though the increasing in premises from 67 previously to 68 wasn't significantly noticeable. They still give a huge impact toward the consumption. Since we know that manufacturing sector is the sector that use a lot of water from the water treatment plant, and they have been dominating for 4 years straight as the biggest sector to consume a lot of water intake to fulfill their demand. Result for objective 2. To determine the blue water footprint of heavy industrial activities in Kuantan River Basin for 2015 until 2018. Based on all 5 water treatment plants, it can be seen that in year 2018, the blue water footprint for heavy industrial activities are the highest for all water treatment plants. It can be seen here based on the red arrow that shows for all water treatment plants. Semambu, Bukit Ubi, Sungai Lembing, and Mancing recorded 2017 as their lowest lowest in total blue water footprint that was recorded. This can be seen by the blue arrow that shows the lowest volume of total blue water footprint. While for Bukit Sagu water treatment plant, 2015 was was selected as the lowest year that the lowest volume of total blue water footprint. Okay. Result for the third objective is to predict the total water footprint for heavy industrial activities based on deep learning algorithm. For Bukit Sagu, Sungai Lembeng, Pancing and Semambu water treatment plant, prediction data is lower compared to the actual data. Actual data fluctuate a lot because of the existing of outliers. Suggestion is to use the daily data for the blue water consumption instead of monthly to get more better result, because when the gap in the modeling is decreasing, the data that we can get is more accurate. And then uh, the set is 50. Epoch is a term used to indicate the number of passes of the entire training dataset the machine learning has completed. As for the Bukit Sagu, we can see here that the prediction data is higher compared to the actual data and training data. This is due to the lower number of industrial activities that recorded here. In the conclusion, heavy industrial activities in Kuantan River Basin from 2015 until 2018 is inventorized. Blue water footprint for heavy industrial activities in Kuantan River Basin from 2015 until 2018 is determined. And total blue water footprint for heavy industrial activities in Kuantan River Basin is predicted by using the deep learning algorithm. This is the example of reference from my thesis. That's all from me. Thank you.